Kia ora tātou. In this video, we're going to look at how temperature affects the rate of reaction, and you can use this information for the Chem 1.1 practical investigation or the acids and bases end of year exam. So if we've got two beakers filled with acid, they both have the same concentration of acid, so the same amounts per volume, and the only difference is that one of them is at a colder temperature, so let's say one of them is at 20 degrees Celsius, the other one is at 40 degrees Celsius. And we were going to react these acid particles with, again, let's do a piece of metal. Let's give it 6 particles this time. So if we were to put the piece of metal into both of these beakers, which beaker would react with the metal fastest? Well, what happens when the temperature increases is that the speed at which these particles move increases. So they're moving around really quickly, whereas these particles are just moving around quite slowly. And so if we put in the piece of metal into this one, the particles are going to collide with the metal more frequently. If you can just imagine, that's just because they're going faster. And because they're going faster, they also have more energy. And so that means that more of these collisions are going to result in a reaction. So for a reaction to occur, particles need to be moving with a sufficient amount of energy. So this one will have less collisions per second because they're moving slowly. This one will have more collisions per second because they're moving quickly. And of the collisions that occur here, more of those are going to result in a reaction. So how would you write that in an answer? So first of all, I would describe what the temperature actually does to the particles and making sure that you're specific about what you're talking about. So the acid particles, or if you could, if you're talking about HCl or H2SO4, it's always a good idea to be specific about what particles you're talking about. So as the temperature of the acid or the HCl increases, the particles move faster, or the HCl particles move faster and have more energy. So there's two parts to that. They're moving faster and they have more energy. So let's break that down into 2 points. So the first point is that they're moving faster here. So because they're moving faster, there are more collisions per second because of the faster speed of the particles. And then the greater energy means that a greater proportion of the collisions result in a reaction because of the higher energy of the particles. And then we tie that all in together and we say that therefore there will be a greater frequency of successful collisions. So greater frequency of successful collisions, you need to say frequency because in both situations there's only going to be 6 successful collisions because there's only 6 metal particles to collide with. It's just that this is going to take in the lower temperature beaker, this is going to take a long time, and this is going to be fairly fast. So the key thing is that the frequency of collisions changes, or the frequency of successful collisions, so the collisions that actually result in a reaction, and therefore the rate of reaction will increase. So kind of 3 steps to doing this. So first of all, talk about what happens as the temperature increases, so the particles move faster, have more energy. What does that mean? So faster particles mean more collisions per second, and a higher energy means a greater proportion of successful collisions. And then what does that mean for the rate of reaction? The rate of reaction increases. Hope that helped. Thanks for watching. See you next time.